Hi everyone, my name is Siamak Paulson and this is my geoengineering podcast. In this episode, I have a special guest. As you can see, Rob McIlwraith is my guest today. After 5 years, Rob, that we did the initial podcast in 2020
During COVID?
during COVID.
Yes.
Yeah. So 5 years later, we're here and doing this second one now. So welcome to this podcast, and thanks for accepting my invitation.
Thank you, Siamak. It's always a pleasure to be here with you on these podcasts, and I appreciate your time, and it's an honor to be here. Thank you.
Thank you very much. So, Rob, just a quick flashback to what we talked about 5 years ago, essentially your career and how you started in engineering. And today I just want to maybe talk a little bit more about your involvement, particularly with mining and with tailings. So maybe we start with that and then go through the other questions later.
All right, great. Thanks, Siamak. In general, I started off as a civil engineer. Studied civil engineering back in the day, a long time ago now, probably more than 30 years ago or so. I started off as a consulting engineer, so I was involved in designing roads and bridges and all various water supply things. And one of the interesting things I did was a distillery, actually. Designed a lot of structural steel and tanks and things for a big distillery making 27,000 litres of alcohol a day.
Nice.
So I tried to follow people's advice and not mix business and pleasure.
Exactly.
But that was a fun game. And then I also did a bit
Can you do that again?
Oh, I would love to.
Backyard.
I would love to. That would be quite a fun project. But I think we've got to stay on the focus path now. Otherwise, you could get distracted a bit too much.
Absolutely.
But I enjoyed my time as a designer, and then I got involved in some landfill designs and on-site monitoring of these, and actually got exposed to geotextiles, geogrids, geocells. So I actually found that very interesting. And then I moved actually into a manufacturing kind of role, making geosynthetics, geotextiles, geogrids, clay liners, and then recently into the geomembranes. Over the last 11 years, I've been working for AXTA, as you know, making the Colotange geomembranes. Really enjoying that. I mean, the Colotanges are widely used in lots of mining applications around the world. It's very, very good in tough conditions, good puncture resistance. So we're dealing with a lot of the big mining companies around the world. The likes of, I'll say a few names, but all of them, but the likes of Rio and BHP and Glencore and these type of guys, as well as lots of mid-tier people. So the tailing storage side is a very interesting side to be in. It's challenging. There's lots of regulations coming now, which is improving the sort of regulation around them, which we totally endorse. That we feel that there's been too much haphazard sort of design of these things over the years. And I mean, we just saw the recent one in Zambia where and you've had lots of failures in Brazil, etc. So those are real tragedies. People as well as the environment are getting affected, and obviously it's good to see the industry lifting their game. And we like to play the part in that. We do well in areas where the regulations for environment are high, because our material is a multi-layer composite. So it's not the cheapest piece of plastic around.
That's right.
But it's got a lot of technical advantages. So where the companies want to do the best for the environment, and they can spend a bit of extra money on those solutions, that's where we are working a lot. So we're working a lot here, obviously in Australia, but in Europe and in North America, Canada. We do a lot of stuff in the high altitude mines in South America, in the Andes. So all actually, in the mining field, lots of big projects all around the world, and we're very lucky. We're involved on tailing storage facilities. Some of the biggest mines in the world, for example, the world's biggest lithium mines, huge big copper facilities, really huge big gold mine, tailing storage facilities. Amazing. We're doing one right now in the Pilbara for magnetite. We've done quite a few already, but these are lots of them are multiple phases. So the guys see how well it's performing and they just keep going. So you raise it up and you keep going. And the advantage for armor type of material is that it can be used in the heat without a lot of wrinkles. Other types of membranes wrinkle a lot in the heat, and when you're loading on top of them, you've got the chance of stress cracking coming. So ours has got puncture resistance and no wrinkles. So those are the sort of, and it's heavier than water, so the specific gravity is 1.22, so it's going to stay underwater. It's not going to float up. That's like other types of membranes. So in the mining space, we do a lot of like the sort of tailings from the embankments and the base. But as time goes by, we've also done a lot of capping of old tailings storage facilities as well. So our material is obviously very impermeable. So but it's tough, and you can put various types of other
and waste rock dumps.
And waste rock dumps as well is a big application as well.
Water storage dams on mine sites.
Exactly, mine water processing ponds and big storage dams. We do a lot of those actually. So we're quite heavily involved in the mining field, and our material works extremely well, and on these projects. I guess every sort of project is like challenging. You need to design it correctly. You need to look at all the sort of aspects of it, whether all the sort of things that come with it. But there's a lot of very good design engineers here in Australia and around the world, of course. But it's a specialized field, and it needs a lot of around technical information. But we're happy to be involved in those things, and we like to see testing and sort of the game being sort of raised, and we're happy with our material because you can do all sorts of things with it. Like it's an engineering material that you can pin it, you can put all sorts of aggregates directly on it. You can reinforce underneath it. So there's lots of things to play with, and it makes life challenging. You can also go a lot steeper than other types of membranes, and that saves these mines a lot of money. So they're getting economy with the subgrade preparation, the rock fill, as well as the advantage of it's very difficult to puncture it.
That's right.
So it's adding a safety factor there.
Absolutely. I think many advantages that this product provides, and mining space, like everything in mining is big. The scale is something that the designers and engineers need to consider, and also like the remote nature of a lot of these mine sites, and being able to deal with the challenging conditions, whether it's temperature, whether it's like the steep slopes, or the requirement for like even trafficking on some of these material, putting rocks on top of it, and like you said, wrinkling and operational advantages as well. That's very fascinating, Rob. I think one thing that we kind of touched on in our previous episode is like I'm quite amazed when I hear about your travels. And every time we get together for a dinner or a lunch or a drink or something, we talk about some of your interesting travels. So tell us about like interesting places that this job has taken you. Maybe some of the challenging mine sites. Which is probably more interesting for our audience.
Thanks, Siamak. Well, I would say I'm lucky in my life. I've been able to travel to more than 50 countries around the world. So I love traveling and seeing new things and experiencing different cultures and different foods, but different mine sites as well, and different ways of people working. But like particularly even here in Australia, there's some amazing places that I've got to see that I probably wouldn't have got to see in otherwise. Like lots of these very remote places in the Pilbara, where we're doing these huge big tailing storage facilities. In Western Australia, you have to actually fly in there with a plane. Otherwise, it would be extremely difficult to drive there. Some places around Kalgoorlie in the middle of the desert. I'm thinking about some nice places. We've done some good work on mining, TSFs in Tasmania, beautiful parts of the world which are getting protected with, by the Colatonche. They want to look after the environment, so they they do the job properly, which is great to see. We've also doing a lot of work in remote parts of Queensland, which I'm very happy to have had the opportunity in my work to sort of see these amazing places.
Yeah.
So I do love that. In terms of overseas, we do kind of places like in crazy places as well. But I'm just thinking about. I mean, we've done some work in the sort of wettest mines in the world. That's one's called Oktedi in Papua New Guinea.
Yes.
Yes. So they get 10 meters of rain per year, and it's the wettest mine in the world. So to put any other type of membrane down, it's just too wet.
Yeah.
And our material, you can lay it when it's raining, but then wait for a gap in the rain, and then dry that seam. You pull off the self-release tape, and then flame bond it, and you're fine. And that's the kind of thing we like, those challenging mines. But in terms of a craziest place that I've been to, would probably be Djibouti. It's in the East Africa, right next to Somalia. It's a bit of like when you look on the travel advice, it says don't go there.
Don't go there.
There's a bit too much sort of terrorism and things around there.
Yeah.
But on the one side you've got Eritrea, then you've got Ethiopia, and you've got Somalia on all bordering around it. So a little bit of some unusual people there, and you get a few but it's most of the people are lovely, but you got to be careful.
Yeah.
And we're driving through the desert, and we're designing building this kind of actually a dam to hold water, because it's very dry there and hardly ever rains. But when it does rain, they want to collect it, so they wanted something very tough for that scenario. And you're driving and you're seeing camels, and you and you're way off the there's no roads where we were going,
off the
grid, no water, just camels around. So those were the type of interesting kind of places I've had the opportunity to see in my life. Yeah.
That's right. Oh, that's very interesting.
Yeah.
And like I said, we always hear very nice stories, and sometimes scary stories of your travels, and Djibouti is a place to hear about. Anyway.
Thank you. Interesting.
So then, Rob, we talked about some of the mining applications, mainly of this product, Colotange, specifically a bituminous geomembrane. But I also know about a lot of non-mining applications, like in roads and lots of other applications. Just tell us about some of the non-mining applications of this product.
Thanks, Siamak. Yes, the Colotange is like a very versatile type of geomembrane. It's got the polyester reinforcement and the very flexible bitumen. The elastomeric bitumen, so that's the SBS that gives you that flexibility. So it has a wide range of sort of functions where you can use those properties of puncture resistance and no wrinkles. So like landfill cappings is a big one, or capping of contaminated land as well. I think it's got a long track record of capping of like very sensitive, serious waste like nuclear waste in Europe for more than 25 years. So it's got a very good long track record on tough environmental challenges, and it's good in those type of applications. In terms of water, it's used quite extensively for water canals, and potable water, big dams. It's also used, as you say, in sort of transport applications. Next to roads, you might have some water drainage ditches that you want to channel the water and flow in these canals, or temporary water storage ponds next to the roads. That we do a lot of that. Underneath some big projects on runways, where we've got dispersive and expansive clays, and they're very moisture sensitive. So you want to seal off these areas from changes in moisture content. So they basically put Colotange all the way across underneath the railway and underneath the runway, and then seal up on the side, and then you've kind of locking in that expansive clay
Some
that you've got in there
isolation.
for that.
More
Yeah.
isolation.
It's also used underneath railway tracks, actually.
Yeah.
So you stopping the fines pumping up through into the ballast. So it's the strength of the colotange from the internal reinforcements means it's very good in these tough applications. And it's used on bridge decks as well, actually, to provide bridge deck waterproofing.
That's right.
So you can, and the benefit of that is you can actually put the hot asphalt directly on the type of liner. So other types of liners would be destroyed by the heat.
Sure.
Because the asphalt's going down, it's through 160 degrees.
That's right.
So our material can handle that.
Yeah, that's very very
Other things are erosion protection of embankments. There's quite a few inland from here, actually.
Correct.
On some of the gas projects,
like the external
batters, where it's more cost effective for them to actually just seal it and then stop the rainwater taking away that dispersive clay. So it's used in a multitude of different applications as well.
Yeah. And the fact that this product comes in a kind of a wide range and variety, so it's not just one grade.
That's right. Yeah. So depending on how tough you want your application, if it's just a lightweight sort of erosion control, you can go for the lighter grades. We have products going from 2.2 millimeters thick right up to 5.6 millimeters thick. And the heavier grades have an internal reinforcement of 400 grams per square meter of polyester, and also 50 grams per square meter of glass fiber. So it's very heavy duty on the higher range. And if you want extreme like UV protection or damage protection, then you go for the thicker ones. And if you want a waterproofing function, but you might be covering it with soil or something, then you can go for a lighter grade.
That's right. And then also, I think also like something that I just thought about, the recent improvement that you guys are making into not just the product and manufacturing, but also your design and construction. A new release of your handbook.
Yes.
Yes. Do you want to talk about that?
Yes, sure. Thanks, Siamak. Just for information, here it is. Here it's the latest colotange design and application handbook. I'll just show it here, but it just gives you a lot of technical details about the product, how to use it, anchor trenches, drainage below, that type of thing. It also shows storage, aggregate covers on top of it, the type of installation conditions. All of this based on sort of 35 years of experience all around the world. So it's nice to have, we've had similar ones in the past, but this is the updated version. And it also shows some of the details of some of the unusual equipment that we make that's not made by anyone else. This one here, for example, is the hydraulic beam, which is actually using the hydraulics from an excavator and actually enhancing the speed of installation, as well as making it safer on slopes and also less fatigue for the installers. So very important on tough sites, especially in the Pilbara and where it's worker fatigue is something to be wary of. So this is a document here. Just there's how many pages is it? It's 88 pages. So it is available from us at info@axta.com.au, but and on our website. But we think it's quite useful for engineers just to keep up to date with some of the latest design guides.
Good reference for designers and also for installers. And it also, I just briefly looked at it maybe 2 or 3 nights ago when I messaged you about this. So very, very interesting and covers different applications. And the good thing is the improvements that have been made throughout the years in terms of both design and application and construction. Like you guys had challenges with, for example, like installation speed, and you came up with this hydraulic beam. Applications on landfill caps where you cannot use the flame. and then you guys came up with the
hot air welding.
hot air weld equipment.
Yeah.
So I mean that flexibility and that sort of improvement, that's a very, very positive thing.
We like challenges, and we're constantly improving. Behind the scenes, we're doing a lot of testing.
Yeah.
There's a lot of things. We've got a very good laboratory in our head office in France, but we also use people around the world. Actually, we've got good contacts in the industry and lots of good testing facilities. Even here in Australia, we've got really good people doing amazing tests. So we're very happy, and we love advancing and growing and improving. Actually, it's a lovely challenge, and if someone comes with a challenge, we'll step up and go for it.
Absolutely, that's very good. That's very good. And we released the news about this new publication on our tailings news and landfill news. So just this week. So if people want to find the source of this handbook, there's a link in there as well.
Thanks.
So you talked about your job and places that the job has taken you, or the challenges that you've faced. My question now, Rob, is what do you really like about your job, or what do you most like about your job?
Thanks, Siamak. I like my job a lot. Actually, I think I'm being very lucky. I think when you study civil engineering, you kind of think that you're going to go down a straight kind of consulting engineer path, and I did do that, and I actually loved it, for the time that I did it, and I learned a lot. But I must say, at the moment, I actually love my job more. It's just because you've got a lot of interaction with different consulting engineers, and all at a top level, around the country and also around the world on different things. And we're in a bit of a niche market. You kind of specializing in a few different specialities of that. So you're talking to expert people, most of the time. I love the sort of mix between technical side. So I'm using my civil engineering background, but also you kind of in the business as well. You're looking at shipping stuff around the world, and manufacturing and R&D and things like that. So and it's also the people. I love working with different people around the world. I think I love working with consultants, and there's always a high level of people that you're dealing with. I also like going to sites and being on the ground with the guys, doing that. We give them the training, and we get our hands and our feet dirty, and we don't mind that. We cover them in dust, and that's quite a challenge as well, and good fun actually. And you see what the guys are experiencing on the ground, because it's tough work, when you're out on site. But that's, as you said, that's why we've got the hydraulic beams to make the worker fatigue less. So those type of things. I love the sort of R&D side as well. I love finding new things and improving. So we're researching all sorts of specialized fixations and mechanical strength, and you can do a lot of different things in our type of membrane. The internal reinforcement is polyester, but you can actually put whatever you want. You can put carbon fiber in there if you want to. Obviously, that makes it extremely expensive, but polyester is a very good all-round type of material. It's got it's quite freely available, but it's also got a high melting point at 265 degrees, but it's also got low creep. But it's not perfect for every single application. So you can actually just play around and put some other fibers in if you want, or you can change the additives in the mix as well. You can put some graphene oxide if you want in there. Whatever. There's all sorts of fun things to do and improve and go forward. And that's why I see the industry will continuously get better. And I think it should be like that. Everyone should be upping their game and getting better all the time. So I like that. I'm very lucky that I'm working with a really good team of people here in Australia, but around the world as well. We've got really good colleagues in our different offices around the world. Our head office is in Paris, but we've got a production facility in the north of France. Very good team there. We've got other colleagues in Spain, in North America, in Canada and United States. We've got offices there. We've got our colleagues in Santiago, Chile.
Yep.
All of these guys are engineers, and they're all like giving good things. We've got some real specialists in the Czech Republic, and they handle Eastern Europe and that part of the world, but really smart guys. And so it's nice to interact with these guys and they can give you their international perspective as well. So those are the things what I love about my job. Yeah,
that's right. Yeah, absolutely. And I think it brings challenges with it, which is a good thing. So one thing, for example, I see, you guys have been working a lot in the past 10 or 15 years that I've known about Colotange, is because it's a geomembrane, and you have obviously polyethylene industry there, like with very kind of set testing regime, and like the type of parameters they look for. When it comes to BGMs, bituminous geomembranes, they're kind of looking at the same thing. Right. Like, how can I do a tensile on your product? How can I weld your product? How can I do a weld test on your product?
Yes.
So basically, like the BGMs are not necessarily the manufacturing and the process wasn't exactly the same process as the polyethylene or other industries.
Yeah.
But you're getting questions because those questions have been answered or have been looked for in the polyethylene industry.
Yeah. Well, it's very interesting. There is a very good document actually called ASTM D7700.
Yeah.
You'll probably have it, but for the rest of the people listening, it's a very, very good like classification of all the different types of membranes. And you've got HDP, LLDP, PVC, Colotange, like the BGM, which bituminous geomembranes in there. Mm-hmm. So all the different types of EPDM. So all the different types of membranes are categorized, and then it lists all the different types of testing that you can do for these things.
Yeah.
So you can do destructive testing, which is your standard tensiometer test from site or in the lab. Then you've got non-destructive testing, which is like your air lance testing or your ultrasonic testing. Then you've got the electrical leak detection scenario. So all the CQA guys are getting their game up, and they're doing amazingly good jobs, and it's quite widely known that they will see far less faults on a installation. I mean, the installation team needs to be good and they need to be well trained, but they'll see they'll pick up way less faults on our type of material because it's so rugged and it's got all that puncture resistance. And even on the seams, the 200 mil seams, you've got a big factor of safety there on a 200 mil seam. So they're seeing far less problems on site, actually. In general, the regulation is there. There's enough ASTM, test methods that everyone can test it well and be confident that they've got a well-tested and checked product quality on site. Yeah.
Sure. Yeah, and I think what we always say is basically you need a good designer to select the best material for the application, and then do the best design.
Yes.
For the solution or for the intent they're actually doing it. So it's not a one size fits all.
I agree.
In any application, it's a challenge that the designers and the engineers have to face.
Exactly right.
Yeah.
And I think exactly what you're saying, Siamak, not one type of membrane is going to be suitable for every single thing.
Yeah.
And we're the first ones to say that, and we're quite happy to say, like, if you've got some extreme chemical and very funny pH or extreme pH or something that there may be a better sort of membrane to choose, and we're quite happy with that. But if you look at the wide range of normal pHs, on sort of 3 to sort of 9 pH, you're pretty good, and it's worthwhile testing it with what you've got for sure.
Yeah.
But the Colotange certainly offers you, like in the wide range of good chemical resistance, but then the extra abilities of no wrinkles to get, stress cracking on. Can go on much steeper slopes and much rougher subgrades, and so I think it's a good thing to do. Like a multi-criteria analysis of each job you're working on. So we don't mind if we get compared against other types of membranes.
Yeah.
Because most of the time we will win, so we don't mind.
Yes.
So that's okay.
Yeah, absolutely. I think the multi-criteria assessment is one of the best ways to do it, because it's like, not just even like the technical side, that's probably like, has maybe the heaviest weights, but in terms of the commercials, in terms of the remoteness of the sites, the installation time, and like, lots of other operation, environmental aspects that needs to be looked at. So yeah, definitely good suggestion to do a multi-criteria assessment before you start your design. Very good. That's what we have time for today. Rob, thanks very much again. I enjoyed our conversation, and hopefully not have to wait another 5 years to do that.
We'll definitely make it sooner. Siamak, thank you so much.
Thank you very much.
Very nice to talk to you, and a pleasure to be on. Thank you.
And
everybody.
thank you, our listeners, to listen to this episode. We catch up with you in the next episode. Thank you.
Thank you.